Welcome back. This is Module 3, Lecture 2. This time we're covering valves. Last time we covered pipes. So let's get started. All right. The primary purpose of valves obviously are to start and stop flow, isolate piping, regulate pressure. Um, you typically will never throttle flow with a gate valve, just FYI. It can cause damage to the valve itself. There are globe valves that are better suited for something like that. As you can see off to the right, you've got classifications, many different types of valves. We're going to go over a lot of these throughout this lecture, so buckle up. So valves, are primarily to start and stop flow. Most are intended to start and stop, and they need to be in either the fully open or fully closed position, especially when you're dealing with a gate valve. You have this disc that's inside of there, and that right there is not designed to throttle the flow in a long-term status. Initially, when you're starting and stopping flow, you want to do those things slowly to prevent water hammer. If you allow too much water to flow initially, or if you shut flow off too quickly, you can create water hammer, which could damage your system in some fashion. So distribution valves are going to be installed at, various frequencies. If it's a larger main, they're going to be spread out much further. But within like a distribution system, you're going to see them a little bit more frequently, probably every 500 feet or so. And normal practice is to install at least two valves at each intersection. Uh, I of, I often liked having three valves at each intersection. It allowed for more flexibility in the event of a shutdown. But normal practice is to have two. And if you look at this diagram off to the left, you'll see that there's various frequencies in which the number of valves are installed. And you are going to see valves more frequently at an intersection. And then when you do see a single valve, it might be in the middle or in between intersections, just to minimize the number of services that would be out in the event of a shutdown. Another type of valve you might see is a hydrant auxiliary valve. So when you see fire hydrants as you drive around wherever it is you live, pay close attention to the road itself. You might be able to see a valve lid that would indicate where the isolation valve or the hydrant auxiliary valve is. And that valve there is used just to isolate that fire hydrant if there's maintenance that needs to be performed, or when they get hit. It's nice to be able to shut that down without having to disrupt the service to all your customers. In this image that you see off to the left, one thing that is pretty common nowadays is what we call a hydrant check valve. So when these hydrants get hit, there is a check valve there that will close, preventing water from spraying everywhere and creating a bunch of erosion or damage um, due to that missing fire hydrant. All right, here we have a pump control valve. The valve itself is essentially to stop water from flowing backward through a pump that's not in operation. Um, as you can imagine, water's got to move through there, and this valve acts like a check valve, if you will, preventing water from flowing backwards when that pump is off. Another function of this valve is to prevent water hammer from occurring when the pump is actually started up. And then you've got an upstream valve there to isolate the pump when you have maintenance. It'll typically be a gate valve or a butterfly valve, depending on how your system is set up. Here we have a couple water service valves. The valve in the top is called corporation stop, and that's what's used to connect your service lateral to your water main. This valve is a buried valve, so you're not going to see a handle on it. You're going to see an operating nut. And everyone does it differently as far as like the location. I know at VID we like to install these kind of valves with that operating nut on the side so it's not damaged as you're digging down to it, or there's less likely a chance of it getting damaged. The valve on the bottom right there, that is can be called a curb stop. I've always called it an angle stop due to its angle formation. And these are the valves that you're going to see inside of a meter box that are upstream of your meter. They're used for temporarily shutting off water to a customer for various reasons. But then also to perform maintenance on your meter, you're going to need to isolate this valve. Right. Pressure reducing, sustaining, and throttling flow valves. These valves are my favorite to work on. They're just a lot. If you ever get the opportunity to get your hands on and maintenance these kind of valves, they're a lot of fun, and it really helps you to understand how they operate as well. But these can be used to throttle flow of water, and it's going to be durable over a long period of time. It's got a diaphragm in there that's used to flood and remove water from the cover, and that's how that valve is going to open and close. You'll typically have um, two throttling or two principal types of throttling valves used in a water system. So you have pressure reducing, and then you have altitude valves. Altitude valves would be installed up at like a reservoir. So as the water level rises as you're filling that, you want a valve that's going to shut it down to prevent it from spilling should your pumping get out of control. If your SCADA system for whatever reason malfunctions, or you put in a schedule that doesn't work, and it pops off sooner, that altitude valve is there to kind of back you up. Right, pressure reducing valves. Like it says, used to create two or more pressure zones in a distribution system. I'm sure as much as people like having, adequate or higher pressure, having too much is obviously not a good thing because it reduces the lifespan of like your appliances or your plumbing. So you definitely want to break down that pressure to something that's more manageable, something that you can install a simple pressure regulator at a house. To manage that water pressure. But these will take water from a high pressure zone, reduce that pressure, and then supply it to the lower pressure zone. The control that you see on the side there, those that one in particular appears to be a CRD, and that's going to be used to control downstream pressure. And what it does is that it allows water to move off of the cover. And when the downstream pressure is met, what it'll do is that valve, that small little valve that you see here, will start to close down, which will force water onto the cover, causing this big valve to close. And then they have other types of CRAs, CRLs that will control the opposite. If you're trying to control that upstream pressure, and then anyway, uh, there's many different ways to plumb these, and like I said, you get your chance to get your hands on these. These are a lot of fun to work with. Again, altitude valves, ground level reservoirs usually have them, filled through an altitude valve. So that valve there, like I said, is to help prevent a reservoir from spilling should it get to a certain altitude. And that's what these controls are measuring. These right here, they're called hydraulic controls. So they're solely monitor, like you have springs inside of them that as that pressure moves through it and increases or decreases, that will affect the operation of these valves. So, but they can stop flow completely when the reservoir is full. It's an automatic valve and will keep the reservoir from overfilling and can allow flow in one direction or both directions. A lot of different uses and operations that you can set up for this type of valve. All right, backflows. I'm sure some of you have either gotten your certs or you're getting your certs. I had mine for a long time. Now I just maintain my cross connection control certification. But these are really fun to work with too, if you ever get the opportunity. Yeah, I really recommend you know, take a course on this and learn about them because they are very important. So they're designed to prevent water from traveling back out into your distribution system after it has gone through either a meter or through a fire service. And basically, you're trying to prevent some kind of contaminated source or higher pressure that could be downstream or not, technically controlled by your water system from going back out into your distribution system. So the valves are going to be installed wherever backflow might occur. You see that? Anytime there is the potential for backflow conditions, that's why you're going to have these valves installed. I know recently the cross connection control handbook was updated and requiring every single fire service to have one of these installed. In the past, they were able to get by with just what they call a PIV or a post indicator valve. But now that handbook has come out and stated that, they have 10 years in order to get their RPDAs installed or DCDAs, depending on which one your system requires. Yeah, pressure relieving valves. If you have a closed zone or a zone that doesn't have a regulator on it, you're probably going to want to install some kind of pressure relieving valve so to prevent overpressurization. And again, these can be designed to release some energy created by water hammer. And for those who don't know, water hammer is that rapid increase in pressure. And these typically and water hammers typically caused by opening and closing valves too fast. But these types of valves, so as you can see, here's a different way of plumbing your globe valve. So it just, there's a lot of different ways to set these kind of valves up. They're pretty interesting. So I recommend you get your hands on them if you get the chance. Again, this, in my opinion, is the most important valve in any distribution system. But here you can see you got a nice little cutaway of let's see what is this? Cast iron auto air vent. It's just got a float in there, so as water fills up this, it's going to rise and check. And then if you have a vacuum condition, this float drops, allowing air to travel back into your distribution system to prevent that vacuum from happening. So this is considered an auto air vent or a combination air vent, might be another way of calling it. And then again, we use, just a simple angle stop as a manual air vent in our system in some areas. So, like I said, you can manually or automatically vent air, and it can result in increased pumping costs and restricted flows if you don't have one of these installed. It can lead to water quality issues in the pipeline because that if you get airlock, it can prevent that pipe from utilizing its full volume and potential. We have gate valves. They are the most common type of valve that you're going to find in any distribution system. Again, this is a type of valve that you want to operate either fully open or fully closed. Um, you, I got a little typo down here, but it says that, should not be installed where they will need to be operate frequently because they require too much time to operate from fully open to fully closed. So again, to prevent water hammer, you want to operate any valve, on a, slowly or, at a controlled rate of speed. Um, and if you've got a valve that you need to open and close frequently, then you're probably going to want to go back and install like a globe type valve, a valve that's more adequate to handle that kind of operation. These valves, they should be operated at least once a year, to kind of prevent tuberculation built up and then just ensure that you have a properly working valve. They range in size from, you can see 3/4 inch to 72 inch. One of the limitations that you have though is if you're installing your water mains, to a depth of 3 or 4 feet, well, the bonnet on top of this valve can get so large that this operating nut would stick up out of the ground. And so that's one of the limitations. Plus, these valves cost a lot of money. There are other valves that are, like a butterfly valve, which we'll talk about soon, that is probably better suited for very large mains, but those have their own downside. So you got a couple different types as well. You've got a rising stem and then a non-rising stem gate valve. You'll see non-rising stem typically installed on a buried line. You're not going to be able to operate the valve with a stem that rises if it's buried. And then you won't see a hand wheel either. A lot of times you'll see an operating nut that is installed on top of these that you can fit a valve key on and be able to operate these valves. With the rising stem gate valves, a lot of on fire services, that's where you're typically going to see these valves or in pump stations. Reason being that you would want this type of valve is because you want to have a nice quick indicator if that valve is open or closed. So when the fire department shows up and they can look over and see the fire service or that RPDA or DCDA, they can see that the valve is either fully open or fully closed and have an idea of whether or not they've got that fire service protection. Um, so these right here, it's called a OSMY. That'd be another name for them, and it stands for outside screw and yoke, and it's just another nomenclature for a gate valve. Here you got a horizontal gate valve. Like I said, they could get really large, and so you want to be able to have a valve that you can, or if you wanted to install a gate valve, you'd want to have one that could be operated horizontally to prevent that bonnet from sticking up above ground. Um, so, like it says here, typically 16-inch or larger, usually going to be installed on a main that is not very deep. Inside here, you're going to have rollers that help to assist with the operation of this valve. Otherwise, you're just dealing with more friction and gravitational forces on this valve that will make it very hard to operate. And then they're going to be geared differently. At the end of this, you're going to have a gearbox that may spin the valve quicker, or may reduce the time in which you would operate it, because it is so large. It's going to take a lot of turns to operate. We have some valves in our system that are, a couple hundred turns to operate them fully open to fully closed. So it's nice to have something that's geared differently to allow you to operate it a little bit quicker. So one of the things that was not on the last valve that we just looked at is called a bypass valve. When you have a large valve that's fully closed, you're going to have a lot of force being pressed up against one side of it, making it almost impossible to operate. So you install what's called a bypass valve, and it's just a small valve, typically like a 4-inch valve, that is plumbed to allow water to flow from one side of the valve to the other. And then you would let this valve just fill your line. It may take a long time, but it allows you to equalize pressure on both sides of the valve, making the larger main valve easier to operate. Um, it's important that, when you're selecting valves for any, large transmission mains, that you're taking this into consideration. So here's a nice little cutaway of a sidewinder or a horizontal gate valve. You can see here that this is the main valve or the main operating disc, and as you operate your gear, your main valve operating nut, this gearbox can be geared to allow this valve to open quicker. Down here you've got a track, like I said, a roller that will assist in operating this valve, and then over here on the side you've got this bypass, which will allow you to equalize pressure on both sides. Um, for VID, we use a paint coating system for our valve lids, and that lets us know which one is the main valve and which one is the bypass. So that's always important. You always want to make sure you're operating the correct one, because it'd be real easy to break a bypass valve. operating nut or stem, uh, just because of the small size of them. Resilient seated gate valves. This is what most I think water systems are installing. You want this resilient seated gate valve. Um, they use a synthetic material or a rubber of some kind, and it provides a better seal against the valve body, and offers an easier operation, and leak tight shutoff. So when you're selecting your valves, a lot of times you might see, resilient wedge or resilient seated, but these valves are what's most commonly installed in distribution systems nowadays. Globe valves. Okay. Like I said, you ever get the chance to operate these things or maintenance them, they're really fun. So, you know, get your hands dirty and try it. But they have a circular disc that moves downward onto a valve port, as you can see here, and that will start and stop your flow. And this type can be throttled. Um, so that way, if you need to throttle your flow for a really long time, that's definitely the kind of valve that you want to do that because it's designed to be able to handle that kind of operation. Pressure relief valves, these are very similar to globe type. About the only difference between them is that in this case, the disc is normally maintained against the seat via a spring, and then that spring tension can be adjusted to whatever it is you want that valve to open at. And then, so you've got this spring in here. They make different types of springs with different type of spring tension, and then you would use like a set screw or something to adjust that, and then a locking nut to lock in that set point. So this type, you're typically going to see on a globe valve too. It's almost like a globe valve on a globe valve. But these are like those controls that I was showing you in some of the other images, that you can set to operate a much larger valve and provide pressure relief. Then you have a needle valve. These are, again, similar to a globe valve. The nice thing about these is that you can really dial in for precise throttling of flow. You'll find these on, like I said, globe valves because you want to control the speed at which those operate. You don't want water, if you don't have a way of throttling that flow onto your cover of your gate valve, that globe valve will never open because too much water would be allowed to flow onto the cover. So installing some type of a needle valve there will allow you to control the amount of water that goes on. So that way, when you need water to come off of a cover, you're not concerned that too much water would get onto the cover. But yeah, these are useful throughout distribution systems. Typically on like water quality equipment, you're going to find these. You don't want too much flow going through your water quality equipment. Otherwise, you're not going to get a true representative reading. Diaphragm valves. Um, again, used, for altitude valves. This is a nice little cutaway. You can see how water would flow into. It would push that seat up, or push the disc up off the seat, and then water would continue on down. Um, like I said, you're typically going to have some kind of a hydraulic control on it to control its operation. If you watch that YouTube video, it's a nice little video or animation on how these things operate. Rotary type valves. These are nice. They're used throughout the water distribution system. They can be called either plug valves or ball valves, but they provide really good flows and they have a 90-degree operation. So for quick, you know, service or shut off, you're typically going to find these in like a meter box. We call them customer valves, and we provide these to the customer so that way they can shut the water off if they need to. Um, but they're most commonly used when system pressure is high and a positive shutoff is essential. And there's a lot of different applications for them. Again, they're used on globe valves or altitude valves anyway. But These have a big use in the water industry. Here we go, butterfly valves. I talked briefly about it previously, um, but you have a disc, a rotating disc inside of this valve. So as you operate this valve, this disc will pivot from this fulcrum point here and open and close. There's some disadvantages. Obviously, you have this disc that's in the way as water is flowing, so it's creating a little bit of resistance. And then if you needed to swab or use a pig to swab for cleaning purposes, this is going to prevent you from doing that. Plus, their quick operation can lead to some water hammer. But the advantages to them is that they're relatively cheap when compared to like a gate valve. Um, when you operate them, you have pressure on both sides of the valve as you operate it, so you don't have a lot of resistance as you're operating this type of a valve. So those are that's a couple advantages to them. Check valves, super important. There's typically two of them on your backflow device, right? For anyone who's taking backflow. But you can install these, or have, customers if they want, they install them to prevent water from traveling back out into the distribution system. If a customer has a pump that they need to increase their pressure because you're only providing them the minimum requirement, they might install one of these to prevent their system from losing all that pressure. But again, they're designed to just allow flow in one direction, and they're commonly used at the discharge side of a pump. And there's a lot of different ways that these things are designed. But as you can see here, this is a nice little cutaway. So you can see how this disc here would just float or, function back and forth. So if there is a higher pressure downstream, it would obviously cause it to close. And then when water's needed, it opens up. So different ways to operate valves. You've got manual, electric, hydraulic, and pneumatic. Uh, and then, of course, the method that's used for operating a valve depends primarily on the valve itself and how frequently it must be operated. Right, manual operation, couple different ways. You would have some gate valves or valves in general that have like a hand wheel to them or some kind of handle that you can get your hands on. But in the event that you don't, you've got just this operating nut. It's usually a 2 inch by 2 inch square operating nut that sits on top of the valve stem, and you would slide your like valve key that you see off to the bottom right. You would slide that over that operating nut, and then you'd be able to operate it. Those valve keys usually extend, depending on how deep your valve is. They they make valve stem extensions that you can install on the valve nut, so that way you're not trying to find a valve nut that is several, if it's 10 plus feet deep. It can be often difficult to get that valve nut on there because you might have groundwater that's in your valve stand and making it difficult to find the valve nut, or they get buried with dirt. There's all kinds of things that can happen inside that valve stand. So having a valve stem extension on it's nice to bring it up closer to the top so you can see it more clearly. Another means of operating a valve would be an electric actuator, and it's just a small little motor that would sit on top of that valve stem or connect to the gearbox. And it's turned on by some kind of switch or remote signal, like if, through SCADA. And it would just operate that valve fully open, fully closed, or you can dial it in. If it's connected to a globe valve, you want to, you can send a signal out that would, operate it at 50% if you needed to. Um, but yeah, they continue to operate until it's turned off by some sort of a limit switch. Next, you have hydraulic actuators. Kind of like it says, it's a hydraulic, so it's using some sort of a fluid, typically water, to operate the valve, and you would have a pressure differential across it. So that's how it's moving that hydraulic fluid. But you'll find these in treatment plants or pump stations, um, and you got to be cautious of that water quality condition because it can, obviously, like in Southern California, we have hard water, so you would have scale buildup. So that's one of the things that you would have to maintenance over time. And you want to prevent scale buildup because then it can hinder your valve operation. But then the valve might not be able to operate in the event of a low pressure. So you got to make sure that you have adequate pressure anytime you're installing one of these types of valve actuators. Pneumatic would be air. I'm sure some of you have used like some sort of a pneumatic tool or air compressor. But yeah, another means of operating a valve. You're probably going to find something like that in like a treatment plant where they have that readily available. But they're very similar to a hydraulic valve. They use except that they use compressed air. They can be installed on isolation valves, but more commonly you want that installed in like some kind of a control valve. Um, and then, of course, the downside is that it does require some kind of compressed air system to provide that to it. You want to maintain really good records of where your valves are. This can be very important because most main breaks don't happen in the middle of the day when you have readily available records or I mean, people available to help you. And so having some sort of a record that you can access in the middle of the night is going to be important. So that way you can isolate a main in the event of like a main break. But then also, anytime you have a new project that's coming up, and you're in the design phases, you want to have real accurate records of where each valve is, because that new system is going to need that information in order to be designed properly. Plus, if you have a valve turning program, which that's something that every agency should have. You want to be able to operate your valves at least once a year, fully open, fully closed a couple times. Like I said, help knock off any kind of scale formation or tuberculation, and get those valves working properly. So that the record should contain at least the location, and then relevant to three other permanent. You want to make sure they're permanent objects. Um, so if you're saying, hey, that tree over there is 20 feet away, well, that tree may not be there in 20 years or 10 years. So using permanent objects like a road marker, um, a fire hydrant is typically not going to move too much, or storm drain boxes, any kind of other valve lids. Those are those are some objects that are more permanent that you'd want to tie those 3-point locations to. Looks like I got another little typo there. It says make, and I don't recall what I was trying to say there, so disregard that for now. Um, you also want to make sure you have good records on what type of valve was installed because that could be just as important. Oh, I guess just I see what I said there. The type, like type of valve or the make of the valve, who made that valve, what kind of, who's the manufacturer, and then of course the size of that valve. And then the number of turns to fully operate the valve can be useful as well. Date of installation will let you know if you've reached that useful life or not. Like I said, most valves are typically designed to last 25 years. However, if your valves are only lasting single digit number of years, you really want to, have a good record of that so you can go back to that manufacturer and, maybe see if there's some kind of warranty. All right. Wouldn't be a class without a little bit of math, right? So when you're dealing with valves, like I said previously, you're going to have a lot of pressure or force that is applied to, a closed valve. So one side of that valve, you'll have likely 0 psi, but then on the other side, you could have upwards of a couple hundred psi. And so understanding how to calculate force, it can be useful. I know I saw it once or twice when I was taking distribution exams. So let's go through it real quick here. So we know what pressure is, right? That's the measure of force or weight pushing against a specified area, and that's usually going to be in square inches or square feet. So PSI, right? Pounds per square inch, all right? Or PSF, which be pounds per square foot, be another way. If you're dealing with something much larger, in inches doesn't make sense. And then you've got force, and force is that push or pull measured in terms of weight, such as pounds or kilograms. And force on the bottom of a tank. So anytime you have a reservoir that's installed, you can calculate out what the force or of the weight of that water is on that foundation. And so you want to make sure that, of course, the ground itself can withstand that. So let's see. I got a prop here. Here we go. So pressure will depend on the contact area. If you set a brick on the table and it's 7 pounds of force, the weight, it's spread over 32 square inches. So what is the pressure against the table at that point of the contact? So you would just take that 7 pounds and you divide it by the area, and you would get 0.2 pounds per square inch. However, if you were to take that same brick and turn it on its end, and you have that 7 pounds of force that's now just spread over 8 square inches, you run the same calculation, 7 divided by 8 this time, and you'd have 0.9 pounds per square inch. So the orientation can definitely impact the force that's applied. All right. Let me know if you got any questions or comments. If you have problems with the homework or something doesn't make sense, definitely reach out. But otherwise, I hope you have a great week. Bye.